I would like to present agentic AI methods to support reasoning and consensus in ICANN policy deliberations. The core contribution of this work is structured reasoning support. So, for example, we can take a real LGR public comment proceeding, additional reference label generation rules, and related updates, including the updates in Arabic scripts. And in that kind of process, the record is already distributed to different technical and procedural sources, and what I'm proposing is a structured, step-by-step, human-controlled process in which AI helps analyze material and generate transparent reasoning artifacts. So the flow is straightforward. The comments go in, the system then decompose issues and retrieve the evidence, and it produces structured outputs, and finally, of course, human review everything. And the boundary is crucial, so AI doesn't decide, doesn't vote, and doesn't determine policy outcome, and doesn't replace the people, of course. So the challenges here is not just the volume and a huge number of documents, but also the complexity, because in that kind of processing, community trying to reason across several kinds of materials at once, and interviewing new and updated reference LGRs across several scripts and languages, including Arabic, Japanese, and Latin-related languages, and they go across public comment and draft updates, background explanations, and supporting technical materials. And all while understanding how these documents should relate to DNS stability, implementation consistency, and usability. And this creates a real risk. So important concerns can be missed, ambiguous may remain unresolved, and assumptions may stay hidden. And it also slows down the progress because first people should reconstruct the record before they can evaluate it. Next, in technical proceedings like this one, the input may involve ICANN organization, technical experts, language communities, public commenters, staff, and participants with different priorities. So some of groups can focus on script accuracy and language representation. Others may focus on security and stability implications or implementation feasibility, consistency with existing LGR structures, or alignment with relevant ICANN reference materials. And the key questions become very practical. So who supports what and why? Does disagreement lie? What remains unclear, inconsistent, or unresolved? And these questions are difficult because they involve a lot of actors with a different perspective. And the same issue can be from different technical or policy language. So the methodology, the first system breaks the review into specific technical questions like which LGRs are new, which should be revised, what script or language each change affects, and what kind of change is being proposed. Second, it retrieves the evidence from ICANN materials and sorted organizes the evidence into structural outputs. So, for example, it can show which changes are being proposed for what language, justification ICANN organization provides, which comments support the change, which request clarification, and technical or implementation concerns. First, it checks for gaps and conflicts. It can identify unclear rational, unresolved variant issues, possible inconsistencies across the LRG sources, and places where the impact of rule change is still underexplained. And fifth, of course, it iterates as new comments arrive or revised versions are updating, and outputs also can be updated with source links and changing tracking. And the point is make the review of complex LGR changes more transparent and traceable. So here's use cases that we can use. The first one is synthesizing multi-stakeholder feedback. So the input could contain comments, stakeholder statements, and working group drafts. And the output would be a position matrix with citations. And for example, we can see that one stakeholder group may express conditional support because public interest safeguards are needed, and second may express caution because DNS stability risk aren't defined, and another may support a proposal because it sees as proportion to risk. And it helps participants see agreed and dispute points faster, and it preserves two minority views instead of losing them into general summaries. And second use case is identify gaps and missing technical clarity in draft policy text. So here's a system checks for ambiguous or undefined terms, internal contradictions, and unstated assumptions. So assumptions like who will implement something with what timeline and which dependencies, and also a very useful question, if the proposal is adopted, what changed, what breaks, or what else is affected. And the system generates clarification questions and suggested edits, each linked back to the relevant source text. And it helps working groups focus discussions, whereas the draft is focused on a least clear or weak point. So a more realistic approach is a pilot. And the best pilot will be low risk and high value. For example, one public comment proceeding or one working draft cycle. And a fixed corpus of documents should be the first selected, and then the system would generate a set of artifacts such as position matrix with citations and open issues list and a trade-off summary. And after that, SEO and IS participants would review, validate, contest, and correct the outputs, and updated versions could be then published with change logs and source links. And success would be measured by whether this reduced the time of map positions, reduce unresolved ambiguities before consensus calls, and produce traceable outputs. And of course, here governance is important because AI used in ICANN policy deliberations. And first, it should be transparent. So every output must be cited and source linked. And of course, reproducibility because the same inputs should produce traceable outputs. And of course, human in the loop and natural facilitation. So the system shouldn't advocate for a position. And of course, there are also important risks that should be manageable, like hallucinations, false certainty, biases in summarization, overreliance on AI, and privacy exposure in input materials. So the outputs should be auditable and contestable. And the last one, so I will close it with 3 takeaways. So the first, ICANN policy work faces scale and complexity challenges. And second, agentic AI can help by generating structuring artifacts. And third, none of this should be adopted without human oversight. And overall logic is also simple. So documents go in, then agentic workflow, clarity and traceability, and better deliberation. So not better governance by replacing people, but better deliberation by supporting people. And I want to close my section with practical questions like which ICANN process could be the best for pilot and which output format would be most useful for it. And thank you very much for your attention.
Thank you, Kristina. Any questions? Yes, Hugo, go ahead.
Hi, my name is Hugo. Have you looked into a specific policy or is that part of the future work? How does your work?
Okay, so here's the first example that I provided. It was about label generating rules with updated Arabic scripts. So I looked on this specific policy for the first example.
Okay, any other questions in the room? Alfredo, go ahead, please.
Alfredo Calderon, again, a mentor for the NextGen. My question for you, Kristina, has to deal with the process that we use now in policy development process. When you mention the way you would like it to be handled, do you foresee then that the process of implementing the policy will be shorter or not?
Okay. I think I'm not fully understand your question. So you mean if my changes will be really workable or?
Yes.
Okay, I think yes, because the most important thing is that it's not replace the people, it's not replacing your view, it's just try to summarize whole facts or internal contradictions that we can have, because we can proceed with a lot of documents, and agentic workflow can help with it, because first of all, it's working not with whole documents itself, so you can put your documents in chunks, and agentic workflow, if working with RAG, augmented generation. So first of all, we can create the vector embedding and store it in vector store. And when AI agentic needs to work with some important part of the document, it can take the relevant chunk of the document. And it's really easy for agentic AI to work with a lot of documents than for people, and then people can see more clearly, for example, position matrix, all views, all comments, and everything important, and then can decide what they can do with it.
Thank you so much, Kristina.